Hey guys, this video tutorial is for all those beginners who are interested in programming digital circuits using VHDL. In one of my videos, I have already told about programming digital circuits using Verilog in all the three abstraction levels. So similarly here, in the case of VHDL, we can program any digital circuit using the three abstraction levels, that is data flow, behavioral as well as structural. So in this video, I will show you how to program a digital circuit using structural modeling in the case of VHDL. So before that, I would like to tell you the general syntax for writing a simple VHDL program. Apart from Verilog, in VHDL you have to create a separate entity for declaring inputs as well as outputs. So that is the reason why the general syntax goes like this. You have entity. So entity is a keyword. Entity name, it's an identifier, is. Then port, you have to list the ports. Let me say, for example, you are simulating AND gate. For AND two input AND gate, A and B becomes input and Y is output. So I write list of inputs as A comma B, and in stands for input, out is output, in out for sequential circuits. Then after in you have to write the data type. Data type can be either standard underscore logic or either it can be bit. So this bit, it means that A and B can take 0 and 1 if you are declaring the data type as bit. If you are declaring it as a standard underscore logic, it can take any values, that is 0, 1, X, Z, L, H and so on. So this complete is a declaration of the entity. So you have to start with the entity and end with the entity name. The entity name should be same wherever you are declaring. After that, the main program at all the three abstraction levels is written inside the architecture. So for that, you are writing architecture as a keyword, then arc name, architecture name, that is nothing but the identifier what you are giving of which entity you are using for writing the architecture. You have to write the name of that. So this is an entity name. So the same name I have to write it over here is. Then any declarations, if it has to be done, those things has to be done before the begin of architecture. Let me say in Verilog, you declare wires. The same, internal connections can be declared over here in the case of VHDL also, but before the begin of architecture. In the case of Verilog, you declare the internal connections as wire. In the case of VHDL, you declare something called as signal. Then you have to write space signal name, after that a colon. Then you have to declare the data type of the variable what you are using as an internal connection. So again, it can be either standard underscore logic or either it can be bit also. Then you have to write begin of architecture. After that, you have to write the actual program in any three abstraction levels, and after that you have to end the architecture name which you have declared while declaring architecture. So this goes with the general syntax of VHDL programming. So let us go for the Xilinx software which I have already installed. So we'll go for file. Again the same procedure follows similar to what we have done using Verilog. File, new project, I have to give the project name, I'll give as mux1. Then I'll go for next. In this, the simulator should be ISA simulator, either it has to be VHDL or Verilog. Next, then I'll go for new source. Then I'll go for VHDL module. Since I'm writing a VHDL programming, I am simulating a simple digital circuit, that is 2:1 multiplexer. So I'll give the name as mux1. Again, you can give any name. So this name will be nothing but the name of the entity. Then I'll go for next. Then I'm simulating a 2:1 multiplexer, as I've already told in one of the video where I have simulated using multisim, wherein I have told that your multiplexer is a controlled switch. Based on the select line, the input passes to the output. For a 2:1 multiplexer, you have one select line, two inputs, one output. If I make select line as 0, your output Y will be equal to the first input, that is I0, and when I give S as equal to 1, your output Y will be equal to I1. So there are totally 3 inputs including select line and one output, so I'll declare it as I0, I1, then I'll declare it as S, one more input, and then I'll declare it as Y. I0, I1, S are inputs, then Y is output, so I'll declare it as out. After that, it is next, finish. Then your file will be saved with an extension .vhd for VHDL. Then next, finish. So the initial entity declaration, everything need not to be written again, it will already be created over here. See, it is already created entity name is port, I0 in standard logic, I1 is also in standard, S is also in standard, and Y is out standard logic. All the four different variables can take different values for the combination, that is 0, 1, X, Z, and so on, as I've already mentioned. Then you have end of the entity name. Then architecture name, you can change the name also over here of entity name is mux1, which is already declared is. Then I have to declare over here, since I'm doing this video is about structural modeling of multiplexer, 2:1 multiplexer. Let me come back over here. What is the general syntax for following a structural modeling? I'm doing a 2:1 multiplexer programming. Now, as we know that your output expression y will be equal to s bar I naught plus s into I1. So it is not of s. So not of s, then and with I naught, then or with s and with I1. So this is a data flow modeling of your or. It is not the symbol in the case of VHDL, it is or. So this is a general data flow expression for a VHDL programming of a 2:1 multiplexer. So whenever you are doing structural modeling, you have to see that you will create a components. So what are the components that we have used to get the final expression over here? One is not, next it is and, next it is or. So there are totally three components which need to be created. If and you have to also see how many operands you are using for the different operators here. And or as well as not are operators. Not for obvious reasons, it has one input and one output, and it can have multiple inputs also. But in this, for a 2:1 multiplexer, you can see that there are two inputs, that is not of s and I naught. For the next AND gate, again there are two inputs, yes as well as I1, which means that AND is operating in this program for two operands. Even OR is operating on two operands. If I take this complete as one entity and the other as one, so that it is again acting on two operands. So I'll split up over here. I'll write SB as equal to not of S semicolon, or need not be. Okay, next after that it is AND operation, AND of I naught and with not of S. Already I have declared it as SB, so I'll declare it as an output Y1. Next I'll write for output again Y2 is equal to S and with I1, and the last one, it is a final output what I have to get. I'll write it as Y is equal to Y1 or with the Y2. So the same thing we will write over here in the main program, but it is a structural modeling what we are doing and not a data flow modeling. So I have to create three different components. Component is always created by using a keyword called as component, then space. Then I have to create three different components. One is AND, but I cannot write AND as it is, because AND or XOR, XNOR, NOT, NAND, NOR, all these are bitwise operators what we use in VHDL. So these cannot be used as an identifier. So I'll create a component called as AND1 for AND. Then I have to write what are the inputs and what are the outputs. As I've already said, here AND operators in this program is for two operands. So I have to declare two operands. So it can be I1, I2 in standard underscore logic semicolon. Then O, I'll declare it as out standard underscore logic bracket close semicolon. Then I have to end the component. I'll write it as end component semicolon. So over here, it is not compulsory that you have to use the same variables as S, I naught, I1 and so on. You can give any variables. You can give A, B and C also, doesn't matter, because we are only creating the components which is telling the compiler on how many inputs are there and how many outputs are there. That's it. Next, I'll create one more component for OR. So I'll write component OR1, then I'll write port inside the bracket. Again, I can pass the same values because it is only mentioning about input as well as output port. So in standard underscore logic semicolon, then O as out standard logic bracket close semicolon and component. Then again I have to create a component for NOT gate. I'll give it as NOT1. Then port, since it has only one input, I'll write it as I in standard underscore logic. Then O as out standard underscore logic, bracket close, semicolon, end component semicolon. Now, as I've already told that in this particular program, I am using variables, internal variables, that is y1, y2 as well as sb. So I have to declare this by using a keyword called as signal, because similar to Verilog what we declare as wires signal, I'll declare it as sb comma then y1 comma y2 colon standard underscore logic. I have to define the data type for the variables what I'm using. Then it is begin. In the begin, I have to map all the ports over here. So I'll use a mapping the ports by using a label. I'll give it as x1. You can give any variable name. I'll give it as x1. Then I have to map the ports. I'll use a keyword called as port map. Then port map, inside the bracket I have to pass the parameters. What are the parameters over here? First we are doing a NOT operation. So NOT operation of yes we are doing. So I'll write the input parameter as yes, as I've already used, that is input, and then the output is SB semicolon. You can follow any order, you can write the output first and later input, but the order should be same when you are writing the program for a NOT gate. Next I'll write for AND gate, then it is port map, then inside the bracket I'll pass the arguments. Over here you can see that I have to perform the AND operation of SB and I naught, and the result has to be stored in Y1. So I'll come back over here. So I'll write SB comma I naught comma output is Y1. Then X3 I have to give one more label. Then port map I'll write. Next it has to perform the AND operation of yes as well as I1. So I'll write it as yes comma I1 comma and the output is y2 semicolon. Next I have to create give a component for port map. Then it has to perform the OR operation over here of y1 and y2. I'll write y1 comma y2 comma then the output over here is y semicolon. But please remember that here whenever I give port map, your compiler doesn't know that it has to do a NOT operation. So I have to call which component over here for performing NOT operation. It is NOT1, which I have already created. So with the name as NOT1 I'll give. And here again it has to do AND operation and one space port map. Similarly and one space port map, and last it has to do OR operation. So I'll give OR1 space port map. So this is how you write the structural modeling. You do the port mapping by the component name and then by using a keyword called as port map, and inside the bracket you have to pass the parameters. So once it is done and behavioral is already present, I'll save this. The moment I save, 4 instances of NOT and as well as OR will be created. So let us see. I'll save. Over here you can see that NOT1 and OR1 is already created. Now I have to write the program for OR and as well as NOT, because the compiler won't be knowing how to do the operation. So over here I'll click on NOT1, right click on this, the same procedure, new source, then VHDL module. Then I'll write the file name. The file name should be same name as the one which I've created the component. So I'll write it as NOT1. Next, the input is I, output is O, out, next, finish. So the declaration is done. Now I can follow any kind of modeling. Let me take a very simple example for a data flow modeling in VHDL. Here the NOT operation, OR operation, AND operation are all written with respect to the operator, bitwise operator, AND, OR, NOT, and so on. So since it is doing NOT operation, I'll write O, and unlike in Verilog where we use assignment operator as equal to, in the case of VHDL we use less than or equal to in the case of VHDL. So out is equal to NOT of yes, the NOT of I over here. I is the input, O is the output, NOT of I. So this completes the program for NOT gate. Next I have to write the program for AND gate. So and any one and you need to write, because both are operating on two operands and performing the same operation. So right click, new source, VHDL module. I'll give the name as and1. Then next, I'll give the inputs as I1, I2 and Y as a O as output, out, next, finish. Here I have to perform the AND operation. So I'll write O less than or equal to I1 and with I2 semicolon, save. Next, again you no need to write the AND program for the next instance. Only you have to write the program for OR. Right click, VHDL module. I'll write OR1. Next, so port name is I1, I2, output is O. So I'll write out, next, finish. So now here I have to write the program for OR. So O again the same, O is equal to I1 OR with I2 semicolon. So the programming is done for multiplexer, 2:1 multiplexer. Now we'll go back and check for the syntax. I have to select this mux. Then under implement design, rest procedures are same, similar to Verilog. So implement design, under synthesize, check syntax. So this will check for syntax now. This will take a while because it has to check the syntax for all the programs what you have written. Meanwhile, one thing you need to remember that in the case of VHDL, the variables what you use are not case sensitive. In the case of Verilog, the variables or the identifiers what you write are case sensitive. Now the check syntax has been compiled successfully without any errors. So we'll go for checking the functionality by using a test bench rather than writing the stimulus again. So we'll go for behavioral simulation. Procedure remains the same. I'll click on mux1, right click, new source. I'm creating a test bench waveform for the multiplexer. So I'll give the name as TB or any identifier you can give. It will be saved with an extension .tbw. Then I'll go for next. Here you are getting different options, mux1, not1, and1, or 1. You are applying test bench to the main program, that is mux1. So I have to click on this, then next, finish. You get a pop-up window now wherein you have to select over here. Since it is a combinational circuit, I'll select for this and I'll go for finish. Now I have to give the combinations for the corresponding I0, I1 as well as yes. Let us see now. I'll give a random combination, need not to be the same any sequence. Again here I1 I'll give the change and then select line. It can be either 0 or either it can be 1. Then I'll save this. I'll close this again. Now I'll come back for tb.w Xilinx ISC simulator. I'll go for simulate behavioral model. You should get a waveform now. Yes, I have the select line I0 and I1. I can select this and drag anywhere I want. Then using a single marker, click on marker, place it anywhere and you can see the change in logic. Now let us verify. Now select line is 0, I0 is 0, I1 is 0, so Y will be 0. We do not know which logic is that, whether it is I0 or I1 has gone to the output. Now let us proceed over here. Now you can see the change. S is 0. When S is 0, your output to Y should be equal to I0. When S is equal to 1, your output should be Y1. You can see that when S is equal to 0, I0 is 1, your output is also 1. Even though I1 is 0, it won't affect to the output. So irrespective of what is the condition for I1, your output will be same as I0 when S is equal to 0. Now let us see when S is equal to 1. When S is equal to 1, you can see that I0 is 0, I1 is 0, Y is 0. Somewhere over here I can check. Yes, when S is equal to 1, I0 is 0, I1 is 1, Y is 1, which means that Y is nothing but equal to I1 for S is equal to 1. So this is how you check for 2:1 multiplexer. Thank you for watching the video. I hope you have liked. If you like this video, please click on like button and subscribe to my channel for more videos. Thank you.